Hey, welcome back to the second part of our algorithms lesson number 4. So for this particular video, we're going to look at just writing a singular algorithm, but in both pseudocode and flowchart to sort of practice how that all sort of goes. Because realistically, when it comes to making algorithms, it really is just practice. It is having a look at other people's algorithms. It is having a look at problems and solving them using pseudocode or flowcharts. And yeah, just lots and lots and lots of practice. And even coding helps big time in terms of knowing the concepts behind Python and how computational thinking works in terms of like using a sequence, using an if statement or a selection, and using repetition and when you should use those things. So look, the big thing I'm going to say is at the beginning of this, you can pick whatever algorithm you prefer. If you prefer pseudocode, run with it. If you prefer flowcharts, run with it. Okay. Most kids end up using pseudocode purely because it's very much just coding on paper, but you are welcome to use whichever one you want for the simple fact that most exam questions that I've ever come across, and this might still be the case in software engineering, they will just say, write an algorithm. They tend to not dictate what type of algorithm they want you to produce. However, you do need to know how to read and error check both of them. You quite often will get given any kind of algorithm and you need to discern it. Okay, so once you've picked your lovely algorithm that you'd like, you then practice the absolute hell out of it. And the big thing for me is when you are writing an algorithm, it's a little bit like planning an entire project. You're going to break it down into as many little steps as possible. So for example, you first of all read your problem and say, what does this algorithm need to do? You then identify what kind of data you're going to need. You then write out what steps you're going to need in your algorithm. Okay, and it doesn't matter what order you put those steps. You just put down every single thing that you need to achieve on a bit of paper or whatever. And then you place them in order. And that's why I say just put them in any order. Just try and get those brain farts out of the head onto the page. And then finally, write out your lovely algorithm. Okay, and bit by bit. So what I'm going to do for the rest of this video is we're going to run through an entire scenario from beginning to end. And that scenario is, I would like you to create an algorithm that will identify the type of a triangle being provided by a user based on just the 3 side lengths. So for example, you start the program up and it said, what's the side of length A? What is the length of side B? What is the length of side C? And the user types in 5, 7, and 9. And then it's up to our program to identify what type of triangle that one is, purely based off the measurements. That is all. No angles, nothing. Okay. So with that said and done, let's start thinking about our steps. You go, okay, I know what's required. We have to identify the types of triangles. So that means we should go and do some research on different types of triangles and what's out there and what makes each different triangle special. And we'll do that very soon. We then identify the data and go, okay, well, our data that we need, the inputs are side A, side B, and the length of side C. Those are our data. Our output is literally just what type of triangle it is. So that's fine. We can do that pretty easy. And once we've figured out the types of triangles, we're going to figure out the steps and the order. Let's quickly jump into what this is. What types of triangles do we have? Well, basic types of triangles, not getting too complicated. We have got an equilateral triangle, we have got an isosceles, we've got a scalene, and we have got a right angle triangle. So these are our 4 main types. We've got 3 sides, 4 types of triangles we need to identify. If you'd like, pause the video and just using these diagrams or your lovely brain and knowledge of year 9 mathematics or even earlier, try and identify how would we figure out which triangle is which based off that. So give it a pause. Okay, how do we identify these triangles? Well, the really cool thing is these diagrams have got the little red lines and blue lines. The red lines are the ones I'm going to pay attention to. These red lines indicate which sides are equal. So for an equilateral triangle, all 3 sides must be the same. Well, it's in the name. All of it has to be equal. So if we've got a triangle with 3 equal sides, it's equilateral. So side A, B, and C are going to be the same. Isosceles, 2 of those sides can be the same. Okay, one is different, but two are the same. A scalene, none of them are the same. They're all completely different. And then a right-angled triangle, this is the tricky one because it's almost like an isosceles, but it's got this right angle of 90 degrees there. And we don't have any information about the angles inside the triangle. And it's almost a scalene as well because that can be taller, but still have the exact same angle. That can be shorter or longer or whatever. So how do we figure that out? Well, that's when we bring in Pythagoras. So our steps are check if all three sides are equal, check if just two sides are equal, check if no sides are equal, and check if the third side squared is equal to the first squared plus the second squared. If that equation works, if this is equal to this, we have a right-angled triangle at that point. Okay, so if you don't know what this is Pythagorean's theorem, and it calculates the length of the hypotenuse, and we can take advantage of that to basically determine if the hypotenuse has the right length, it will be right angle. If it has the wrong length, it'll be a scalene most doubtedly. Okay, so what is the order? What order do we do these in? This is the really tricky part, is figuring out which one should we check first. Obviously, with the order, we need to get the sides first. So we'll do that. Let's assume that's done. Which one of these should we check first? And again, pause the video, have a think, come back. All right, so the order in which we should do this one is really simple, so it's tempting to do that one first. And then this one is almost as simple, but with one little difference, so it's tempting to do that second. And this one looks very easy, tempting to do that third or even first, really. And then this one is quite complicated, and it's probably the hard one to sort of put into place. First, second, third, or fourth. Now, in reality, this one, the right-angled triangle, has to come first. And there's a couple of reasons for that. The first reason is because these sides could be equal. So it could be confused as a scalene, isosceles. If those two sides are equal, we could confuse it for an isosceles when it's actually a right-angled triangle. The other thing is all sides might be different. This might be taller and that might be shorter, which means it's a scalene based on these rules. But it still has the right angle, so it's a right-angled triangle. I just realized it says right triangle, not right angle. Whatever. So we're going to do right angle first. We'll do that. Then we'll do the equilateral, then the isosceles, and finally scalene brings up the rear. So this is the order in which our algorithm has to attack these four. And realistically, we've got everything we need. We've got the three sides. We've got the four different types of triangle, what order we're going to attack those triangles. And it's realistically now just time to put it into pseudocode and into flowchart. So I'm going to jump into Visual Studio and we're going to have a look at how to code this in pseudocode. Give me a second. Okay. So if you're writing pseudocode, you must start with the word begin. Whoops, my caps lock was on apparently. And you must finish with the word end. And you should give it a name. So let's call this triangle types, like so. Now I like to put brackets at the end, just because in most programming languages you do have brackets, and quite often you send parameters to functions. We'll talk about that later. Now we've got our function, triangle types, and the first thing I said we need to do is get the three side lengths. So let's do that now. Let's get side A, and side B, and side C. Okay, so there's our three sides. So we've got all three lengths, and now it's time to start identifying the different types of triangles. So I want to identify the right-angled triangle first, based off that slideshow. So we're going to use our good old friend, the if statement. Remember capitals for the if. And we if side C times by itself, because that's the same thing as squared, equals side A times itself plus side B times itself. Then we print right-angled triangle, like so. Then end if. So this is step one, 100% done with our pseudocode. We've got the right-angled triangle. We've got the correct formula. Now I could have used to the power of 2 symbols or something like that, but I've just decided to stick with that. You probably notice that a lot of the concepts from programming carry over into pseudocode. The equal symbols we just use a single. You can use a double if you want. We still use an asterisk to indicate times and all those kind of things. So let's jump in. What's the next one? We're going to do another one for the equilateral. Let's come under here before the end if, else if. Now, equilateral means all three sides are equal. So I'm going to say side A, equals side B. And capitals, because it's a key word, side B is equal to side C. Now, I could do that slightly different. I could have said if side A is equal to B and A is equal to C, that's the same thing. We're going to print, whoopsie doodle, equilateral triangle. Okay, so there's our first two triangles complete. Time for the scalene. So scalene said if only two sides are equal. Now it doesn't matter what two sides are equal, but it must have at least two sides that are equal. So I'm going to go else if again. Side A is equal to side B, or side A is equal to side C, or side B is equal to side C. Then let's print our good old friend isosceles triangle. I always have to think about that when I do it. Okay, so we've got three types of triangles handled now. What about this little fella over here? Well, nothing is equal. Now I could do an else if, or I could just do a simple else. I'm actually going to do an else if for this, just to show you something. So if side A doesn't equal side B, and side A doesn't equal side C, and side B doesn't equal side C. Okay. We're going to call that a scalene triangle. Okay. Now, what the hell is going on here? This is a less than and greater than that have been jammed together. Well, there are some types of programming languages that use the diamond to indicate a not equal to. Sometimes, like in Python, we use an exclamation mark equals. Sometimes it's a double equals, but all are valid. You can use whatever one you want. I've just wanted to use this one to show you a different type of does not equal. So here we go. There is our pseudocode for checking those four different types of triangles. Now, excuse me, what I'm going to do next is we are going to jump into Microsoft Whiteboard and I'm going to show you how I would draw it using a flowchart. Okay, so you could do this realistically in Microsoft Visio. There's another one called that I love, diagrams.net. It's fantastic. But I wanted to draw this one because I figured it'd be a little bit quicker. It might be a little bit messier, but whatever at all. I'm going to grab my drawing tablet and we're going to jump in here. So let's start off just like with pseudocode. We have to have begin at the top and it has to be in that rounded rectangle sort of bizzo just to make sure it's, separated from the process. The next thing, we need to get side A, B, and C. Because it's an input, we're going to use the parallelogram like so. And we're going to put get side A. Then we're going to do the same thing again, parallelogram, get side B. Last but not least, let's do, you guessed it, get side C. Okay, and we'll connect all those together. Boop, boop, boop. So there's our wonderful beginnings of our flowchart. Now, as you can see, I'm not the best drawer in the world. I apologize. Perhaps I should be using the ruler tool, but I'm trying to do this fairly quickly for you all without rushing too much. Okay, so it's time to jump into the if statements. Now, if you think back, what symbol do we use for the if statement? That is going to be a diamond. And my rules are do not draw the shape of a diamond first, write the words, then draw the diamond around it. So the first one is our good old friend, the right-angled triangle. Now, because I'm writing on paper, I can simply do side C squared equals side A squared plus side B squared. And then we trap him inside a gigantic diamond. And we've got to draw two lines coming out of this fella. We're going to have one line coming down here, which is going to be our true line. And we're going to have one line coming out here, which is our false line. So if this decision is true, then that means we need to print the message. So let's print right angled triangle. And then we'll put a rectangle around him because he is a process. Okay, I'm going to leave this guy here and we're going to focus on the false path over here. Because what we have got now, boys and girls, is we have got a nested if. Okay, if you remember from the last video, a nested if, oh look at that, my Control Z's working today, is where you've got different decisions that all come one after the other. So let's do our nested if. Our second one was the good old friend of the equilateral triangle. So all three sides are equal. So let's go side. Oh, I might put this down a bit further. Side A is equal to side B. And side B is equal to side C. Diamond time. Again, big fat diamond apparently. Two paths, one down there, one across here. That's the false path, just to keep it consistent. That's the true path. If this is true, we've found ourselves an equilateral triangle. So, equilateral triangle, like so. Box around. Whoop. And here's the fun part. What about the next one? So let's go a little bit further across and down. Arrowhead. So the third one was our good old friend, the isosceles. Two sides are equal. So let's go side A equals side B. Or side A is equal to side C. You could do this in any order, really. I'm just doing it this way because I like it. And side B equals side C. Diamond to indicate yes or no. Ah! Oh my God, that's shocking. Okay. True path, this way. Come with me. Okay, this will be the false path. So what are we going to print? We're going to print whoop-de-doo. Isosceles triangle. I always stuff up that spelling. Okay. Now this time around, because I've got so many goddamn decisions, I'm actually going to utilize the else as such. So this one, we're just going to feed directly into another process down here. And this one's going to print our good old friend, the scalene. Because that just seems nice and easy to do. All right. Holy dooly, there's a lot of stuff there. Now, with this particular diagram, it's messy. It's going all over the shop. I could have gone down to the right, and that probably would have fit better on like a landscape bit of paper, but whatever. The last thing we need is all of these must travel to an end terminator. So we're going to start with this one here, because this is like the spine, the up and down portion of my flowchart. So begin is there. I sort of want end to be in line with it. Do I have to? No, you don't have to. Do I like it? Yes, I do. Down here, let's write end. Put that rounded weird rectangle there. And what I'm going to do is each one of these processes is simply just going to go into that line just to match up. Okay. And this one could even probably go into that line. A little bit messy, but there is our final flowchart. Okay, my fat head's not in the way, is it? Nope. We begin here and we travel down to our first if statement. If it's false, then we travel to here and here and here, and that goes to end. So that is how we create both pseudocode and flowchart for that particular problem. So your next step really is to go and find as many problems that you possibly can and practice as many different algorithm types as you can. So thanks for watching, guys. And the next one, we're going to learn how to troubleshoot these fellas.